Next up, let's talk a little bit about careers in engineering, why you might want to pursue one, why a lot of people see value in it, and what kind of opportunities might be available to you if you decide to pursue one of our CEAS majors. So, why choose a career in engineering? The first part, the thing that I think matters most, is there's a lot of opportunities for career fulfillment for our students. So opportunities to be creative, to solve problems, and again, to design things that matter and positively impact the world. There are some more practical reasons too. So let's talk a little bit about career prospects. One, really excellent job security. A lot of students seek out careers in engineering because they know that long term they are going to have a stable job outlook, a consistent source of income, and no shortage of things that they can do or apply for in order to maintain the life that they want to live. We're going to talk about this a little bit more later on, but there is also a ton of career mobility opportunities for students and professionals with backgrounds in engineering technology, and computer science. And then everybody's favorite topic, engineers make good money. So let's talk about each of these a little bit more. Let's break down that job security, financial stability piece first. Okay, so we are going to start by looking at some data about UC's engineering programs in particular. So these are from 2015, 2016, so they're a little older, but I think they still give us really great insight for what I'm hoping to chat about today. So what this shows us is the number of students who were employed or on their way to graduate school, and the number of students who were still seeking positions within 6 months after graduation. So over here on the right, outcome rates for graduates. Within 6 months of graduating, 75% of this group of students had full-time position. Another 13 were on their way to graduate school, so to get master's degree, PhD degrees, maybe even law school, medical school, lots of different places our students go. And then at this time, 11.6% were still unemployed and seeking positions. So again, this is a 6-month outlook, and we think that this is very encouraging. The other thing I want to point your attention to is over here on the left. This shows you the average and median salary for UC students who were employed post-graduation. And you can see that median and average salary, so their starting salary in their first full-time role, sits right around $60,000. So this is a really great place to be. If you come back to this resource later on, you can see some of the top employers where students are hired after they graduate from UC's CEAS programs, and you can see some of the places where our students do go on to get those graduate degrees that I mentioned earlier. Okay, so that's some UC level information. Let's look at some national information as well. There it goes. Sorry about that. Okay, so you're going to find this article from February 2018, kind of looking at the employment pay and outlook for engineers. So this first graphic shows you the median wage as well as the new jobs projected over a decade between 2016 and 2026. So this is pretty relevant. And what you can see is that there is a ton of job growth in some of our most popular disciplines over the next few years when you will be entering the job market. I also want you to pay attention to these median annual wages. You can see that these are significantly higher than that average median rate right after graduation, and that makes sense. So what I want you to take away from this and from the other graphic on this page is that you will have long-term a much higher in earning capacity that will truly afford you a lot of stability and comfort throughout the rest of your professional life and beyond that, even into retirement. So coming back to this topic of career mobility, I mentioned it earlier. What we basically want you to know about an engineering degree is that it is a golden ticket. I'm not saying engineers can do everything, but the reality is they can do a lot of things because they develop such a broad, diverse skill set, such an aptitude for learning technical and complicated, really theoretical material, but also the ability to teach themselves and thrive in rapidly changing and developing environments. So, engineers have extremely high career mobility, meaning that they can work in a lot of different industries and roles, regardless of which of our disciplines they choose or whether or not it is within an engineering industry at all. The reason why is that there are some common threads across all of our majors that show up in all kinds of industries like healthcare, aerospace, petroleum, you name it. So engineers at their core are trained to design and improve products and processes, systematize safety and lean practices, really engage in high-level systems and operations analysis, and manage projects. And these are things that happen on pretty much every team that you can think of. So what you want you thinking about is, where are you going to be most successful? Which classes are you going to succeed in and gain the most enjoyment from? And which disciplines enable you to work in the industries doing the kind of work that you can most imagine yourself doing? Something else to really just keep in mind is that many of our students end up applying their skills to non-traditional pathways. Things like consulting, technical skills, law, some of them go on to teach. There are so many avenues that you can take with the degree from engineering, and that alone is a huge value in and of itself. So this is a very rough chart to give you an idea of what I mean, what I'm trying to say here. The purpose of this graphic is to show you all of the things, and this isn't even an exhaustive list, that a student with a Bachelor of Science degree in electrical engineering could do. Over here on the left, you see all of the continuing education opportunities a student in this scenario might pursue. They get a Master of Science, Masters of Engineering, Masters of Business Administration. You can go into law school, medical school. Maybe you go on and get a PhD in engineering education, or a related discipline like physics or chemistry. So a lot of students, you saw it on that earlier graphic, about 13% go on and continue their education in some of these fields. Let's say that's not your jam, and you decide to go right out into industry. Up here at the top, you can see some examples of industry paths for electrical engineers, embedded systems, nanotechnologies. So maybe you do take a very traditional engineering role right after graduation. But you don't have to. In fact, you could even apply for other roles that are seeking students with expertise in other disciplines or in other industries. So for example, there are a lot of opportunities in biomedical electronics and computing, energy and lighting systems. So you could even find yourself applying for roles that are designed for biomedical or architectural engineers, depending on the exact skill sets they are looking for. Maybe you don't do any of this. Maybe you go right into technical sales, where you are focusing on selling this kind of technology to companies and really using a lot of those customer service, communication, interpersonal relationship building skills that we wouldn't even typically apply to engineering students. We've only covered a fraction of this graphic. Maybe you go on and teach in higher education. Maybe you are an independent consultant, so kind of opening up your own business and going around and meeting with companies to share your expertise. Perhaps you go right into a management role, never actually do or only do for a short time that kind of frontline engineering work, and then you start supervising large-scale teams, projects, processes within your selected discipline. So again, this is just to help you see how much is out there and how many different choices you're going to get to make along the way to figure out where you fit best. So to kind of tie it back to why you're here, to our change major and transition processes, what this means is that we want you to think more broadly about what is possible with the majors that you are applying to, especially if you are very narrowly interested in some of our more competitive majors with higher GPA requirements like aerospace, mechanical, biomedical. Just because you want to be an aerospace engineer or work in the aerospace industry does not mean that you have to get a degree in aerospace engineering. So there are going to be a couple of resources linked on our Canvas page that I encourage you to check out. The first is a brief video that talks about all the different, and basically it gives an overview of engineering, but the portion I want you to pay attention to talks about all the different types of engineers who might work on an aircraft. The next link down below is a glimpse of a podcast where you can hear someone who works at NASA's Jet Propulsion Laboratory talk about her decision to switch from electrical engineering to geology because it ended up being a better fit for what she hoped to do at NASA long term. And then we even have a UC example, a student who really hoped to be an aerospace engineer but found her passion in electrical engineering and has even done 2 co-ops at this point at NASA. So we want you to be open-minded, and as you're thinking about which programs are going to be best for you, we want you to work a parallel plan. So at any given time, I want you thinking about your top choice major and other paths that you could take to get to the same end goal. And when you do that, what I want to reassure you is that it's not about a lack of faith. It's not about not believing that you can hit the GPA for aerospace. It is about wisdom, knowing that life happens, things play out differently than we expect, and constantly working so that if you do end up on your plan B, it's a plan B that you feel really good about and are certain can get you to the same place you were hoping to go with your plan A. So one of the resources we'll share in the Canvas course is our CEAS Parallel Planning Guide. What this shows you are some common majors within engineering that students will choose if they are interested in one particular subset of majors or another. It also shows common majors outside of engineering that students typically go to if they realize CEAS isn't quite a good fit, and opportunities for students who get undergraduate degrees in non-CEAS majors to eventually go on and get master's degrees in engineering. So check out this guide and think about what would be my plan B, what is my parallel plan, and talk with your advisor should this impact how I'm planning for courses or submitting my application whenever that time comes. Okay, that's all for now. The next video you'll see me will be one talking about preparing to apply to a CEAS major. See you there.